Let's go to question number 215. Kth largest element in an array. This is medium question. Let's get into it. Find the kth largest element in an unsorted array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Okay. Let's check with example 1. In this case, the second largest is first is 6 and the second is 5. So we needed to return 5. And then example 2, case 4. So first is 6 and the second is 5, and then next is 4. So we're gonna return. Does this make sense? Okay. Let me explain with example 1. Okay, first approach, we're gonna use sort. In this case, first we're gonna sort nums, and then we're gonna sort. This is 1, 2, 3, 4, 5, 6. And then return this one. Or we also use reverse option 6, 5, 4, 3, 2, 1. And this time we needed to return this one. This one is 0, 1, 2, 3, 4, 5. So we're gonna return k minus 1 index. In this case, time complexity is n log n, and space complexity 1 in case of in place. And then second approach, we also able to use heap. In this case, let's use this one. And then we make heap, and we will iterate. And then when we here, we put 3 here, and then we're gonna use bin heap to 3. In this case, we don't increase it, just put 1. We use push part, so 1, 2, 3, and then we're gonna pop smallest one. 5, put 5, and then pop smallest one. 6, 5, 6, and then 4, put 4, pop 4. So finally we're gonna return 5. Does it make sense? In this case, time complexity is n log k, and then we needed a little bit space of the k size. Okay, and then last approach is we're gonna use quick selection. In this case, average time complexity is big O n, and then worst big O n square, and space complexity is the constant if we use it in place, in case of place. Okay, did you hear about quick selection? This one is came from the quick sort. So if you're familiar with the implementation of quick sort, maybe you could easy to understand. So okay, this time I'm gonna implement first, and then I also use some example, some simulation while implementation to understood more easily. Okay, cool. So first I'm gonna make 2 functions. First is we need the partition that is same as quick sort. So left, right, we need the index. And then second, we also need select. This one also left, right, and then one more is we're gonna use index. So we're gonna sort the ascending order. So in this case, let's assume this one is already sorted. K2, second largest one is location is here, right? So in this case, but we're gonna check with from the index, so we needed to convert K2 index we're looking for. Actually, we're looking for value is 4. So we're gonna write the name K smallest, that is makes sense. So in this case, K next is 4. If K is 2, so we're gonna make this one, and then finally I'm gonna return select start to left, start boundary is here, left here, and then right here, and then find the how can I say, the biggest one, the 2, that is the same of array ranking, right? So first range of searching must be all. So it starts from 0 and length nums minus 1, and then k small is how we able to calculate it. Okay, let's case 2 is we needed to return 4, right? So in this case, we needed to start with length num, that is 6. 6 minus 2 is 4. Oh yeah, that's right. So we need to minus k. The reason is it starts with 0, so we did not minus 1. In this case, we also need plus 1. So this one is this up here. Does this make sense? So okay, cool. So let's make a start first. Okay, if the range is no range, and at that time this one is answer, right? This one is similar of binary search, command and conquer. So if left is right, and then I'm gonna return nums, anyone is same, right? I'm gonna use left, and then I make the quadrant. Quadrant is I'm gonna use partition. Left I'm gonna use left and same range, and then in this case I'm gonna use the random value. That is quite interesting. And then this is region, how we are able to make averages and okay, random, and then rand int left and right, that is range. And then okay, let's start to make partition. In this case, let's say nums is here, approach 3. Now left is here, right is here, right? And then okay, smallest is 4, and then index. Okay, let's say index is index is 3. 3 is good. Okay, so this is index, and it came from random random pick. Then now I'm gonna use this one is pivot. So I'm gonna the left side I'm gonna change the smallest for pivot, and then right side is biggest for pivot. To do that, we need to calculate pivot. Pivot value is, in this case, index 3 is 5, right? So this one, okay, let's calculate. Pivot is nums index, and then I'm gonna have to change this one to the rightmost side. So I'm gonna switch this one. So now 4, 5. To do that, nums index and nums right, and nums index. Now it is switched now. So 4 is here and then 5 is here. Okay, now we're gonna start the W is the left. So in this case, here is W. So this one is the index to swap. After swapping, it will gonna increase. And then I also need I. So I will iterate for I in range left to right, or only the boundary, and then if nums I is smaller than pivot, I will do swap. So nums I and nums right and nums I, and then increase right. So to do that, okay, let's simulate it. So now I is 1 W, and then 3 is smaller than 5, so we will swap. Actually I is W same, so swap the same position, so it will just increase. In this case it also swap, increase, for also smaller than 5, right? So increase. But 6 is the bigger than 5, so it did not swap, right? That means only this one is increased, right? So now this one is finished, and then we needed to final thing is to change 5 to 6. Then 5 must be here, and then 6 here, and then this is pivot. The left side is the smaller than pivot, right side is bigger than. Does it make sense? How we gonna do? Okay, cool. So I will change nums I with, I will swap nums I with W and nums W and nums I. Then you're gonna swap 5 and 6, and then what is the current, the pivot point? Yeah, that's right, that is 4. And then this one is the first smallest number in an array. That means even this one is the not solid, that is no issue. And then no need to sorting this one, because we just need the current index, the smallest. So this is for smallest, so we just get this one. Does this make sense? This is the really fantastic part of this approach. So in this case, we're gonna return which one? W. That's right. So return W. Okay. And then finally, okay, now we need to make the boundary small and small, as same as binary search. So in this case, if current is luckily same as k smallest, as same as this one, this is the right way, right? This is for smallest, and then we just return 5. Else, okay, let's say current is smaller than k smallest. So let's say, okay, this one is 2, 1, 3, and then this time pivot is 3. So at this time we let's say W is here, and then this is pivot. In this case, index must be 2, maybe okay, 2 is 1, right? 1, and then this one is 3. Okay, let's say random pick 1, and then pivot must be 3, right? 1, oh sorry, 0 is 3. 0 is 3. So in this case, current is the 2. That is the smallest of the 4, right? 4 is the current k. We need to find, right? So in this case, which area we need? Do we need to search in this part? No need, right? Because k is here, we already know here. Then we needed to increase left area to W. No. If that is W, then we will use this one, just to return it. So that is W plus 1. So this range must be exist K. Does this make sense? So in this case, we're gonna return select left boundary is colon plus 1 to right, and then K K smallest, this does not change, and then else return select. In this case, K, let's say K is 4, so K smallest is 2. Oh, 5. Okay, K is 5, and the K smallest is 1, right? 6 minus 1. 6 minus 5. So in this case, which one we needed to looking for? Yeah, that's right, this part. So at this time is we needed to decrease right minus 1. So then K we're gonna locate, right? Does it make sense? So we need to here, right? So at this time, left with current minus 1 and K smallest, and then we're gonna okay. Invalid. Okay, let's fix the typo. Okay, cool. That is 5, 6. Oh, that is not. This is right? That means, yeah, I is right position, but at this time we needed right position. Okay, run code. Okay, cool. Thank you.